Okie dokie. So let's just see what you got. These two things were given to us. I'm going to shrink that down right there for this picture. And then it says all right angles are congruent. Like, we got to do something with that. So let's see. You could say angle. Are there any other angles besides angle Q? Let's see. That I can make. Do I need to use angle PQR for this? No. The only reason I can use with single letter is because there's only one angle made with angle Q. Angle Q is a right angle. And that is congruent to angle T. All right angles are congruent. Why are we doing that? Because we know that these things are perpendicular, but we need an angle. We know that these are proportional. These two sides are proportional, and now we have an angle that is congruent to each other, and it's included. This is the one that's in between the two sides that are proportional to each other. That's a hint. So, triangle PQR is similar to triangle STV. There are three ways we can prove that two triangles are similar. Angle. We have one angle congruent to another angle. That's one pair. And then we have one set of parallel sides. This set and that set of parallel sides. I'm hoping you know that it's the side angle side similarity. Got to have that little squiggle. That proves that this triangle is similar to that triangle because PQ, this one, in ST, double, they're not congruent to each other. QR, 1, 2, 3, and TV, 1, 2, 3, 4. Something like that. Those guys are all proportional to each other. I'm going to erase those things. Just so you know, side angle side. Next, what are we trying to prove? We're trying to prove that triangle VKR is isosceles. If we're trying to prove that, then that should be our last statement, by the way. So I'm going to put that right here. Triangle VKR is isosceles. That's exactly what we're trying to prove. And we're going to use the converse of the isosceles triangle theorem. So I need something here. The corresponding angles of similar triangles are congruent. Once you prove that this triangle is similar to this triangle, then guess what? Their angles are all congruent to each other. So if I'm trying to prove that this is isosceles, let's highlight which that one is. VKR, that's this triangle right here in the middle. If that's isosceles, then it would be very helpful if I knew if two angles were the same. The corresponding angles of similar triangles. Did we prove two triangles or two angles are the same in this similarity statement? In that picture, are there two angles that are the same? Do we know? Is angle V going to be the same as another angle over here? Don't forget, angle R is congruent to angle V. Why aren't they similar? Because in similar polygons, the angles are congruent. So let me just kind of shrink that one down right there. I love this proof. You should be able to make a proof that's very similar to this if I ask it to you on a test or a quiz, and we'll go from there. Perfect. Do I have the assignment for this one? No, I don't. It's not written, so just in case you need it, homework for 6.3 is page 364, numbers 8 through 13, and 15 through 26. There you go. Have fun.